Now we have two men, A and B, moving to the right with respect to the pole. So we are measuring their displacements with respect to the bird or the pole P at some given point in time. Both the displacements are being measured in the frame of reference of the bird who is the observer at P, and therefore we attach the frame of reference to the observer, which is the bird on the pole. A and B are both moving at the same speed, away from the pole. So as observed by the bird, the speed of B and the speed of A will be the same, and this is the observation from the bird's frame of reference. Although the displacements XA and XB are not the same, the change in displacement of A is identical to the change in displacement of B in the same amount of time, and therefore, as far as the observer or the bird is concerned, A and B have the same velocity. This is how the bird sees it. But if you were to ask A, how do you see it? A's answer would be different. And that is because while the bird is at rest, A is in motion. So let's check out how A would see it. To check what A's perspective would be, we first move the frame of reference to A, since now A is going to be the observer. Let's watch B from A's point of view when they both move to the right with the same velocity. Now when we watch A's point of view, or A is the observer, or the frame of reference is attached to A, we have to think that A imagines himself to be stationary while observing either B or the pole. Now the frame of reference is attached to A and it moves along with A. So in this case, we have a moving frame of reference since the observer is moving. The displacement of B is measured with respect to A, and both happen to be in motion. Now observe that from A's frame of reference, the displacement of B does not change. B maintains the same displacement from the y-axis. And when the frame of reference is attached to A thinks he is not moving. Since B is moving with the same velocity as A or as the frame of reference, from A's point of view, B is stationary or at rest. But from the bird's point of view, both are moving to the right with an equal velocity. And you can see that xB with respect to A does not change, but xB changes. And xB is the displacement of B with respect to the pole or ground. So A is not noticing any change in B's displacement, but the bird is noticing it. So when we write B's displacement with respect to A, we write xB/A. When we define a displacement with respect to the ground, we ignore the slash in the subscript. But here we have to be very specific when the frame of reference moves. The displacement of B with respect to the pole or the ground is greater than 0, but the displacement of B with respect to A is 0. You can clearly see that the length xB with respect to A does not change, while the length xp increases. So now let's put this into a mathematical form. Let's begin by making the bird on the pole as the observer. So we attach the frame of reference to P, and we will observe the displacement of A and B from P's point of view. A and B both move, with B's speed this time being higher than A's. So let's define the position of A and B relative to the position of the pole at some point in time. We measure the displacement of A with respect to P and also of B with respect to P. Now we will use these displacements to define the displacement of B with respect to A. If you ask the bird or observer what is the displacement of B with respect to A, the observer's answer will be the displacement of B with respect to the pole or ground minus the displacement of A with respect to the pole or ground. Here you can see that the displacement of B with respect to A is increasing since B is traveling faster than A to the right, so the relative displacement is changing with time. Now this is the only formula for relative displacement that you have to understand throughout this lesson. But be careful, this is a vector-based formula and will be clear as we move on in this series. In the next step, let's put some numbers to XA and XB so that we can fully understand the relative displacements in mathematical terms, and we will go through relative velocities in the lessons to come in this series. So everything that follows in this current lesson will be static in nature, that is, both A and B will be stationary in their positions. In this example, XA is 100 and XB is 250 meters, and this is as seen by the bird on the pole. Since XA is positive, it would mean that A is to the right of the point of reference or the pole by an amount of 100 meters. Similarly, B is also to the right of the pole by an amount of 250 meters. What is XB with respect to A, or the displacement of B with respect to A? And let's make the bird as the observer, so we have attached the frame of reference to the bird. And this is reasonable since we have been given the displacements of A and B from the pole or from the bird. By definition, XB with respect to A is XB minus XA, so it is 250 minus 100 or 150 meters. This means that B will be to the right of A by an amount of 150 meters. This is how the bird would calculate it. So in other words, we are asking the bird how would A see B's displacement, and the answer is A sees B 150 meters to his right. Now what about XA with respect to B? This would by definition be XA minus XB, or 100 minus 250, which is minus 150 meters. Again, the bird has computed this from its frame of reference, and what this indicates is that B will see A 150 meters to its left, or in the negative x direction. Now let's find out what is XP with respect to B. So what is the displacement of the pole or bird with respect to B? If we ask the bird the question, since the frame of reference is attached to the bird would use the formula XP minus XP. for the bird, xp would be 0 and xp would be 250. So xp with respect to b would be minus 250. That would mean that b would see the pole 250 meters to the left or in the negative x direction. Here we have dealt with a single dimension. Now this formula is also valid for other dimensions, and in the lessons to come you will see how we can use that. The relative displacement between any two objects is the difference in their displacements from the observer's frame of reference.